You think you know what light is. You flip a switch, photons hit your eyes, you see the world. Scientists tell you it's both a wave and a particle. And somehow that's supposed to explain everything. But you're missing the most beautiful part of the story. The real answer isn't about wave-particle duality at all. It's about something far more profound that governs not just light, but the fundamental structure of reality itself. By the end of this, you'll understand why light has no mass, why it always travels at the same speed, why electromagnetic fields exist at all, and most importantly, you'll see the hidden mathematical pattern that makes light possible. The same pattern that underlies every force in the universe. I spent my career finding patterns in the apparent chaos of particle physics. When I first encountered the electromagnetic force, I wasn't satisfied with simply saying light is waves or light is particles. I wanted to understand the underlying structure, the mathematical principle that makes electromagnetic phenomena inevitable rather than accidental. What I discovered changed my understanding of not just light, but the entire architecture of physical reality. Light isn't really made of anything in the way you think matter is made of atoms. Light is pure pattern, pure information, pure structure moving through space and time. And the pattern that creates light is the most elegant example of something called gauge symmetry. Let me show you what I mean. Forget everything you think you know about photons for a moment. Instead, imagine you're looking at the most fundamental layer of reality. Not particles or waves, but fields. Space isn't empty. It's filled with invisible fields that permeate every point in the universe. The electromagnetic field is one of these fundamental fields, and light is simply a ripple, a disturbance, a wave of information propagating through this field. But here's where it gets interesting. This field isn't arbitrary. It has to have very specific mathematical properties to exist at all. And those properties are determined by something called gauge invariance, a type of symmetry so fundamental that once you understand it, you'll never see light the same way again. Imagine you're describing the height of mountains using sea level as your reference point. Mount Everest is 8,149 meters above sea level. But what if you decided to change your reference point? What if you said the bottom of Death Valley is now your 0 point? All the heights would change, but the relative differences between mountains would stay exactly the same. Mount Everest would still be taller than Mount McKinley by exactly the same amount. This is gauge symmetry. You can change your reference point, your gauge, but the physical relationships, the things you can actually measure, remain unchanged. In electromagnetism, you can shift the electromagnetic field by a constant amount everywhere in space, and all the observable effects stay exactly the same. This might sound like mathematical bookkeeping, but it's actually the deep reason why light exists at all. The requirement that physics must look the same regardless of how you choose your electromagnetic gauge forces, mathematically forces certain types of fields to exist. These are the gauge fields, and the electromagnetic field is the simplest example. When I first understood this, it was like seeing the skeleton of reality. All the complex behavior of electricity and magnetism, all the intricate ways that light interacts with matter, all of it emerges from this one simple requirement, that physics must be gauge invariant. The mathematics is breathtaking in its elegance. Start with the simple requirement that the laws of physics should be the same regardless of how you choose to measure electromagnetic potential. Work through the mathematical consequences of this seemingly modest demand, and you're forced to conclude that space must be filled with a field. This field must have specific transformation properties. It must couple to electric charge in a precise way, and disturbances in this field must travel at a definite speed. You don't get to choose any of this. The mathematics chooses for you. And what the mathematics chooses turns out to be exactly the electromagnetic field we observe in nature, complete with all its known properties, derived from first principles. This is what separates gauge theory from mere description. We're not just cataloging the properties of light and electromagnetic fields. We're discovering why these properties are inevitable consequences of deeper mathematical principles. We're finding the reasons behind the rules. Think about a spinning coin in the air. You can describe its motion from many different viewpoints: standing on the ground, sitting in a moving car, riding on a rotating merry-go-round. The coin looks different from each perspective, but certain relationships remain constant. The laws governing its motion are the same regardless of your reference frame. This is the essence of gauge symmetry, and it's what makes light possible. But the analogy goes deeper than you might expect. Just as the coin's motion looks different from different reference frames but obeys the same fundamental laws, electromagnetic phenomena look different when you change your gauge choice but obey the same underlying physics. The gauge degree of freedom isn't just mathematical convenience. It's telling us something profound about the structure of physical law. The field itself has an intrinsic ambiguity built into it. At any point in space, you can add a constant to the electromagnetic potential without changing any observable effect. This ambiguity isn't a bug in our description. It's a feature. It's the mathematical expression of a fundamental symmetry in how nature organizes itself. And here's the remarkable thing. This ambiguity, this gauge freedom, is precisely what gives the electromagnetic field its power to transmit information. Without gauge symmetry, you couldn't have propagating electromagnetic waves. Without gauge symmetry, light couldn't exist. But gauge symmetry doesn't just explain what light is. It predicts exactly what properties light must have. If you start with the mathematical requirement of gauge invariance and work out the consequences, you inevitably discover that the gauge field, what we call the electromagnetic field, must be carried by particles with zero mass. These particles must always travel at the maximum possible speed in space-time. They must interact with electric charge in very specific ways. In other words, you derive photons as a mathematical necessity. This is what I find so beautiful about the structure of physics. You don't have to postulate that photons exist and then figure out their properties by experiment alone. Once you understand gauge symmetry, photons become inevitable. They're required by the mathematics of space-time itself. Let me give you another way to think about this. Imagine you have a violin string. Pluck it, and you get a wave traveling along the string. The wave isn't made of string material. It's a pattern of motion propagating through the string. Similarly, light isn't made of field material. It's a pattern of disturbance propagating through the electromagnetic field. But unlike a violin string, which is made of atoms and has edges and boundaries, the electromagnetic field fills all of space uniformly. It has no beginning and no end. And unlike a violin string, which can support many different types of waves, the electromagnetic field can only support one type of wave pattern, the pattern we call light. This is where the mathematics becomes truly elegant. The equations that describe gauge fields are called Yang-Mills equations, and they show that gauge symmetry isn't just a property of electromagnetism. It's the organizing principle behind all the fundamental forces. The strong force, the weak force, even gravity in some formulations, all emerge from different types of gauge symmetries. By understanding light through gauge theory, you understand the blueprint that nature uses to construct all of reality. Now let's talk about what this means for the famous wave-particle duality that confuses so many people. The reason light sometimes looks like a wave and sometimes looks like a particle isn't because it's somehow both things at once. It's because these are both incomplete descriptions of what light really is. Light is an excitation of the electromagnetic field. When you have a lot of energy spread smoothly across a large region, the excitation looks like a classical wave. When you have a small amount of energy localized in a tiny region, the excitation looks like a particle. But it's the same underlying thing, a pattern in the gauge field. Think of it like music. A single note played on a piano creates a wave pattern in the air. But that same musical information could be represented as digital data on a computer, as grooves on a vinyl record, as magnetic patterns on a tape. The music itself isn't the wave, isn't the digital bits, isn't the grooves. It's the pattern of information that can be encoded in many different ways. Light is similar. It's a pattern of information in the electromagnetic field. Sometimes we detect this pattern as waves, sometimes as particles, depending on how we choose to measure it. But the light itself is neither wave nor particle. It's pure information, pure pattern, pure gauge field excitation. This insight leads to something even more profound. If light is information propagating through a gauge field, then the speed of light isn't really about light at all. It's the maximum speed at which information can travel through space-time. It's the speed of causality itself. Anything with zero mass must travel at this maximum speed. Photons travel at the speed of light not because they're special, but because they have zero mass. The speed of light is the rate at which the future becomes the present. The speed at which cause becomes effect. Einstein understood this when he developed special relativity. But gauge theory shows why it had to be this way. Space-time itself has a gauge structure, and the speed of light emerges from the requirement that this structure be mathematically consistent. Here's something that might surprise you. The electromagnetic field exists even in apparently empty space where there's no light traveling through it. The field is always there, filling every point in the universe, ready to transmit information the instant something creates a disturbance. Light isn't the field itself. Light is news of changes in the field, propagating from point to point at the maximum possible speed. When you flip a light switch, you're not creating electromagnetic fields. You're creating a disturbance in the electromagnetic field that already exists everywhere. The light you see is this disturbance propagating through space, carrying the information that something has changed at the location of the light bulb. This is why electromagnetic phenomena can influence each other across empty space. When you bring two magnets near each other, they interact through the electromagnetic field. When you move a charged particle, it creates ripples in the field that can influence other charged particles far away. The field is the medium through which electromagnetic information travels. But here's the most remarkable part. This isn't just true for electromagnetism. According to gauge theory, every force works this way. Space is filled with gauge fields for the strong force, gauge fields for the weak force, possibly gauge fields for gravity. Reality is a symphony of invisible fields, and everything you see and experience is just patterns of information flowing through these fields. Particles aren't really particles. They're stable patterns in the gauge fields, like standing waves or persistent vortices. When particles interact, they're really exchanging information through the underlying field structure. When particles are created or destroyed, the field patterns are rearranging themselves into new configurations. This gives us a completely different picture of what matter and energy actually are. Instead of thinking of the universe as made of stuff moving through empty space, think of it as pure information organized into stable patterns by the mathematical requirements of gauge symmetry. You are not made of atoms in any fundamental sense. You are made of information, incredibly complex, self-organizing, self-replicating patterns in the quantum fields that fill space-time. Your thoughts, your memories, your consciousness itself, all of it is information processing happening within these field patterns. But this raises a profound question that I've wrestled with throughout my career. If we're all information patterns in quantum fields, what makes consciousness special? Why do some information patterns experience subjective awareness while others do not? The answer, I believe, lies in the same gauge principles that govern light. Consciousness might be what happens when information patterns become complex enough to exhibit their own internal gauge symmetries. Just as electromagnetic gauge symmetry gives rise to light, perhaps neural gauge symmetry gives rise to awareness. Think about it this way. Your brain isn't just processing information randomly. It's maintaining coherent patterns across billions of neurons, integrating disparate inputs into unified experiences, creating stable models of reality that persist through time. This requires a kind of internal gauge invariance, the ability to maintain consistent representations even as the underlying neural activity constantly changes. When you recognize a face, the pattern of neural firing that represents that face is never exactly the same twice. Your brain achieves recognition by maintaining gauge invariance, focusing on the relationships between features rather than the absolute values of any particular measurement. This is the same mathematical principle that allows light to propagate through electromagnetic fields. The more I study consciousness from this perspective, the more convinced I become that awareness isn't separate from the physical world. It's what the physical world looks like when information patterns achieve sufficient gauge invariant complexity. We don't just observe light. In some deep sense, we are light, conscious light, aware of its own existence. And light? Light is the simplest case, the clearest example, the most transparent illustration of how information moves through the universe. When you see light, you're witnessing pure information in transit, unencumbered by mass, moving at the maximum possible speed, carrying news of events from one part of the cosmos to another. Every photon that reaches your eye from a distant star carries gauge invariant information about the quantum field patterns that existed in that star when the light was emitted. You're not just seeing the star. You're directly interfacing with the information structure that constituted the star's electromagnetic field millions or billions of years ago. This is why I find gauge theory so beautiful. It shows us that the universe isn't a machine made of parts. It's a mathematical structure, a pattern of patterns, a self-organizing information system of extraordinary elegance and complexity. Every time you look at anything, a tree, a star, another person's face, you're seeing light that has traveled from that object to your eyes, carrying precise information about the quantum field patterns that make up that object. You're literally seeing the information structure of reality, decoded by your visual system into the experience of sight. But we're only at the beginning of understanding what this means. Gauge theory suggests that all of physics, matter, energy, space, time, consciousness, might ultimately be reducible to information and the mathematical relationships between different types of information patterns. If this is true, then light isn't just electromagnetic radiation. It's a fundamental feature of how information moves through reality. And understanding light fully means understanding the deepest principles of how the universe organizes and maintains itself. The next time you see sunlight streaming through a window or starlight twinkling in the night sky, remember that you're not just seeing reflected photons. You're witnessing the visible manifestation of gauge symmetry, the mathematical principle that underlies all of existence. You're seeing proof that the universe is not a collection of separate objects, but a unified information system, elegantly structured by the most beautiful mathematics ever discovered. Light reveals that reality is not made of things, but of relationships, not of substance, but of pattern, not of matter moving through space, but of information organizing itself according to the fundamental symmetries of space-time. And perhaps most remarkably of all, you, as a conscious observer capable of understanding these patterns, are part of this same information structure. When you comprehend the nature of light, you're experiencing the universe understanding itself through gauge theory, one of its own most elegant mathematical expressions. The light that allows you to read these words, the neural patterns that let you comprehend these ideas, the quantum field fluctuations that enable your consciousness, all of it is the same underlying reality expressing itself through different aspects of gauge symmetry. We are light. Light is information. Information is the fundamental substance of reality. And gauge symmetry is the mathematical poetry that makes it all possible.